In this video, we'll be learning about some of the fundamental facts, or properties, of logarithms. And to do this, we're going to be working with the generic logarithm log base b of some number x. Okay, now let's get started. The first property that we need to make a note of is the following. Regardless of the base b, log base b of 1 is always equal to 0. Now, let's see why that is. If we rewrite this in exponential form, this would look like b raised to the power of 0 equals to 1. And hopefully that should look quite familiar. Remember, any non-zero number raised to the power of 0 will always equal to 1, which is what we see written here. B to the power of 0 equals to 1. And quite simply, rewriting this in logarithmic form leads us to this result. Log base b of 1 is equal to 0. So, for example, if we were asked to calculate log base 2 of 1, that would be equal to 0. Or we could have log base 3 of 1. That would also equal to 0. Log base 10 of 1 will equal to 0. And so on and so forth. Regardless of the base, log of 1 will always equal to 0. Now let's turn to the second property that we need to know. Again, regardless of the base, log base b of 0 is undefined. Meaning to say, if you were to plug log of 0 inside your calculator, you should find that it will send back a message like mathematical error, or some form of error on the calculator. And let's see why that is. Let's assume for a second that log base b of 0 does have a solution. Well, then in exponential form, that would look something like this. It would mean that there is a power, say x, such that b to the power of x equals to 0. But you'll quickly see that you'll never come up with a solution to this type of equation. For instance, let's say we were asked to solve 2 to the power of x equals to 0. Well, you can go ahead and try every single value of x you can think of, but 2 to the power of x equals to 0 will never have a solution. Regardless of the power at which we raise 2, 2 to the power of anything will never, ever, ever equal to 0. And so consequently, log of 0 is undefined. The third important property that we're going to look into, and that we need to know, is that regardless of the base, log base b of x is only defined for positive values of x. So I'm just going to go and write is defined for x greater than 0. So what this means is that numbers like log base 2 of negative 3, that is completely undefined. And let's see why that's undefined. In logarithmic form, log base 2 of negative 3 may not look very shocking. But let's say, for instance, we were to write this in exponential form. Well, in exponential form, if log base 2 of negative 3 had a value, that would mean that there is a power x of 2 such that 2 to the power of x equals to negative 3. And again, you can try all the values of x you want here. You'll never be able to raise 2 to a power and end up with a negative result. That's not possible. So as soon as you have a negative number placed inside a logarithm, that is undefined. So remember, log base b, regardless of what the base b is only defined for positive numbers. And there you have it. Those are the three properties that you really want to make a note of when studying logarithms.